Hey YouTube, today we're going to create this 2.5D procedural mesh section, and as you can see it tracks a player, and as you move along it keeps generating and generating and generating. Create a new blueprint. We're going to pick an actor, 2D Terran, we'll call it. Open that up. Okay, so we're going to do this in the construction script so we can see it update in real time. Okay, so first thing you're going to do is you're going to go to add and you're going to search procedural mesh, and we'll just call this the Terran. Okay, so we'll bring one of these in here. We're going to create mesh section. And if we look at this, it looks like we need a vertex array, triangle array, normals, UV map, vertex, collision, etc. We only really need the vertices and the triangles for this. So what I'm going to do is I'm going to create a variable and call it vertex array. We're going to call this vector, and we're going to make it an array. We'll just get that and plug it right in there. Then we're going to create another one. Call this one triangle array. And we're just going to make this an integer. Bring that in, hook that up. Okay. So now we actually have to create and populate each one of these arrays. So what I'm going to do is I'm going to create a function. We're going to call it create vertex array. And we are going to create a couple inputs. Create two inputs. First one is going to be our resolution, and the second one is going to be our field of view. Cross section of the mesh here. We see we have vertices going in order from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So for each iteration I, we're going to be generating 3 vertices. Now, how do we do this in Unreal? So first we're going to start with our for loop. We're going to set the resolution as our last index. And then for every loop, we're going to multiply the index by 3. We're going to get our vertex array. And we're going to insert. This is going to be for each one of our vertices along each iteration. So we need 3 vertices for each loop. So each loop is going to create both the bottom, middle, and the back vertex of each mesh segment. Okay. So we're going to hook all of these up now. Let's just comment them. Call this base vertex, curve vertex, and our collision vertex. going to pump the index value into each one. Now we have to calculate the x value at each point. So what we're going to do is we're going to add a cube, and we're just going to use this temporarily as our target object. Let's call it target. New viewport, there's our cube. Nice. We're going to bring our target object in. We're going to get the world location. We're then going to split off this struct pin. And we only need the y value here because we're only going to be moving in the left and right direction. So to keep our target centered on the mesh, we're going to divide the field of view by 2. And we're just going to subtract that from the x value. Next, we have to add this world location of the target to the index. That way, as you move across the 2D world, it's going to regenerate this array based on the position of the target. So how do we do that? We are going to first divide the field of view by the resolution, and we're going to multiply that by the index. Next, we're going to add these together. And then we're just going to hook this up to all of my x values here. What happened? Why are we not happy here? Sometimes this decides it's not going to work. Just see if that's better. Yeah. All right. What we need to do is make a function to offset this second vertex up. And we want it to be kind of curvy and random, so we can use a sine or cosine function to achieve that. So we'll just jump over here and create another function. Call it get world height. And I'm going to add the height as the output. Next, we're going to multiply the x value by the primary wave noise. And we're also going to multiply it by the secondary. We're going to use the sine function. Make sure you pick the degree option. And duplicate that. And we're just going to multiply those together. Doesn't really matter the order here. Oh, maybe it does. We'll find out later. Okay, now that our height function is finished, we can go back to our vertex function and we can just bring that in here. We're going to provide it with our x value, and it's going to give us our y value for the curve, or sorry, z value for the curve. Now for the collision vertex, it's going to be the same as the curve vertex, so we can just bring the height in there. And we are going to, actually I'm going to create a parameter for this. And this is going to be called Terran height. Or sorry, collision width. Plug that in there. And then for the height, I'm actually going to, again, create another parameter here and call this world height. And we're just going to add that to the height value, just so we have a little bit of control of where it actually sits. Okay, and I believe that is our vertex array function. So we're just going to compile and save that. We come in here, we can bring the vertex array in. Next, the triangle array. We're going to jump over here, create another function, call it create triangle array. Now for the triangle array, we're going to create a for loop, just like before. And we're going to get the vertex array, we get the length, and because for every entry in the vertex array, there's 3 vertices, we're just going to divide this by 3, just so we get every 3rd entry. And then we're also going to subtract 1, so we don't generate a mesh segment on the very last index, as there's no more vertices after that point. We're going to plug that right in there. Now we're going to need 2 different variations of this I value here, one for each triangle index. Okay, so now time to make the triangles. Triangles. So we have 4 triangles. So we're going to make 4 little boxes here. Each triangle has 3 vertices. So we're going to need 12 entries total into the triangle array on every loop. Let's bring these all over. So we're going to grab the triangle array. I'm going to insert. So we need the indexes. So what we're going to do is we're going to take the index, we're going to multiply it by 3 for the first value. And we're also going to multiply it by 12 for each vertex in the array. Now I'm actually going to set a local variable here just so we don't have so many lines. Call this 3 index. And we'll get another one and we'll just call this one index. And we'll set both of those. We're going to make them integers. So we're going to set 3 index to 3 times I, and we're going to set the regular index value to times 12. The triangles. If we break the mesh down into a very simple 2D image here, we have our bottom vertex as 3i, and then if we go in the same order that we entered them into the array, and 3i plus 1, 3i plus 2, 3i plus 3, we can see that we have triangles A, B, C, D. So triangle A would be starting at 3i, we go to 3i plus 3, up to 3i plus 4. So 3i, 3i plus 3, and 3i plus 4. B, 3i, 3i plus 4, and then 3i plus 1. It doesn't matter what order you go as long as you go in a counterclockwise orientation, otherwise the normals will face the incorrect direction. So like we can start at like 3i plus 4 over here, go up to 3i plus 2, and then down to 3i plus 1. And then D, we can go 3i plus 2, 3i plus 4, to 3i plus 5. So now we're just going to hook all this up. We're going to take, so now to hook all this up, we're going to take the index, and we're just going to plug that into the index value of the array. For this one, we're going to index plus 1, then index plus 2. It's 4. And 3i plus 1. Third one, we have 3i plus 1, and we're going to repeat this process for the remaining triangles. Oh, and one more thing. We're just going to clear the array every time this function is called, just so we reset it in the viewport. Okay. Compile and save that. And we're going to do the same in the vertex array. We're going to clear the vertex array just before we jump into the for loop. And if we jump into the viewport, you see nothing is here. We have to set up the construction script, that's why. So I'm going to create 2 more variables, resolution and FOV. And we're going to plug those into our vertex array. And we're going to bring our create triangle array into the graph here, we should still see nothing. And that's because we haven't set up our settings here yet. So let's try 500 by 32, world height 20. There we go. Collision width 15. Huh. What happened here? So I forgot to change the array values here. So 0, 1, 2. This should be 3. Plus 3. Okay, so I figured out what the problem is. It's because I didn't add the world height to the Z on this one. So if we come back here, we should be left with something that looks like this. So you see if we move the target, the mesh moves with it. Now, we haven't set the heights yet, so we'll come back over to our Terran settings here, and we'll just turn up the wave noise a little bit. Okay, so problem here is that I have one of these the wrong way. So we are going to simply do one of these. Put that in there. And maybe I have to do the secondary. I don't know. We'll see if this works. Yeah, that's much better. There we go. And if we move our target, the world generates along with it. Try turning up the resolution a little bit here. Oh, shit. And there you go. There is your infinite 2D procedural Terran.